Okay, testing, 1, 2, 3. Testing, 1, 2, 3. Okay, ladies and gentlemen, real quick, we're going to get started in 2 minutes. I want you to tell me right now, what game is this music from? What series is it from? This music sounds like it would be a perfect fit for the famous cartoon series. What does it sound like? SpongeBob. This is a SpongeBob game. Super Sponge. Yeah, this music is shockingly good. Like,
I did my dice, and I closed it, and I opened it again, and it's still marking materials. Like, they show up, but
oh my goodness,
they don't show up.
Oh. Huh?
Yeah.
So wait, what are you trying to accomplish?
So I did it, like the materials worked. I wrote the numbers, and I closed it yesterday. I opened it again.
You wrote the numbers.
So like I did all the assignment, right? That it was like texture painting the models.
Okay, yes. Oh, the textures are just gone?
They're gone. The material shows up. If you squint, like you can see that the number 5 is like, on the orb that it shows the material, but it's not.
That's strange. You're using this color. Switch. Selected. This is probably something we need to tackle with SARS, but you're it's strange that it's looking like this. Yeah, it's like this texture is not being reflected at all. Wait a second, what?
Yeah.
This texture has nothing.
Yeah, that's why I'm confused. Because even if you like, yeah, like I did the textures already. I saved it, and it's not. Yeah.
Is there like?
Because even if like when you take textures, it shows the different colors of like.
I think there's a bug. There's like a UX bug at the very least where you can be drawing onto things. Let's see. You can be drawing onto a texture like this, and as you work, you'll see a little star here that says the texture isn't saved. You actually have to go click on save if you want to keep it.
Okay. Because I'd taken those screenshots originally.
Okay, that's good. So hopefully you don't have those. But, okay, let's look at this in turn off. Okay. Ladies and gentlemen, let's go ahead and get to it, okay? I actually think this might be a little bit of a shorter lecture. This might be the first day that you all genuinely get your full 20, 30 minutes to do your daily model, but we'll see how it goes, okay? So if you look at where we are right now, we are right in the middle of that homework 3, okay? Homework 3, textures and UVs. We talked a lot about what a texture kind of was on the Monday, right? And we talked a little bit about what it means to map a texture to all these different faces of our model. We're kind of wrapping our texture around the model, and we are deciding, I want this face to show this part of the texture, this other face to show this other part of the texture. And you have a lot of control over how things look on your mesh, how the texture scales, how the texture rotates, where the texture is. And if you recall, we want to use textures as much as we can. Why? We could actually model tons of detail into the geometry of our meshes. But we don't want to do that. Why? Why not?
Materials are too overwhelming for your machine to process.
Yeah, materials, very expensive to compute, expensive to render. If you have a lot of materials, you're in bad shape, especially if you want to make a game for mobile or if you want to make a game for consoles, which are very underpowered pieces of equipment. What else? What else? So more materials. As you get more materials, performance falls apart. But what else can cause performance to kind of struggle? Okay. Yes?
Materials.
We already said materials. Yeah.
Like extra geometry?
Yeah, the geometry. If we want to go in and actually model details onto our mesh, then we need a lot more vertices. Okay? And our graphics cards, even our mobile phone graphics cards, are pretty good at handling lots of vertices, but if you put too many in there, it's going to start to struggle, okay? But there's also one more big problem with saying, I want to go in and model, okay? I want to go model in all the detail on my model. What's going to happen to my topology as I go in to add all that detail straight into the mesh itself?
Don't you get n-gons?
You're probably going to get tons of n-gons, even if you keep things as organized as you can. Nice quads everywhere, right? Lots of good loops. The more detail you add to the mesh, the harder it is to select the right things, right? The harder it is to build more features into that area of the mesh. It's just getting too busy. It's getting too detailed, okay?
And they all overlap because they're on the same surface, right?
Absolutely. Yep. And so the complexity in general is increasing, okay? It's kind of like this. If you want to go create a warehouse and you are in the middle of the Michigan rural countryside, not a big deal, right? Just kind of buy a plot of land, you put up the warehouse, maybe you need to hook us up some utilities and stuff. Not a big deal. It's easy to model when you don't have a whole lot of stuff going on over there, okay, on the mesh. But you know what it takes to create a new warehouse in the middle of downtown Manhattan, New York City? Okay, you know what it takes? It takes hundreds, thousands of professionals, tons of permits. It takes many years and billions of dollars, okay? And the reason is that there's just so much going on in New York City already. There's so much detail. There's so much congestion, right? And you don't want to mess everything up. It's so difficult to build where there's already a lot going on, okay? And that's very much the case with your models as well, okay? So textures allow us to move the complexity somewhere else. It moves it to the world of 2D, okay? And it keeps our 3D meshes and our geometry simple while allowing us to add detail and preserve our precious performance, okay? So that is a big win for textures. And that's what you're kind of getting a feel for today. The homeworks, okay, are going to take you through a lot of that stuff. And it's also going to teach you how to paint textures, how to use a kind of historical technique called vertex colors, okay? By the way, why am I teaching you vertex colors? Have any of you got to that problem in the homeworks? You're drawing a path, you're drawing the Pokeball, okay? Vertex coloring is a technique that does not use textures. Actually, if you look at a mesh, the idea here is we're going to store color data in the vertices themselves. Usually a vertex stores X, Y, Z, right? But actually, each vertex can store color data, R, G, B, red, green, blue, as well. And this vertex colors is the special kind of historical technique for getting cool colors and patterns and stuff onto a model. Why do I bring it up at all? Well, a surprising number of models still use it, okay? Like this one. So, have you ever noticed, okay, most of Daisy's model uses a texture, but actually her hair does not use a texture. Did you notice that? I don't think it does. Maybe it uses it a tiny bit. Yeah, I don't think it uses a texture. What happens if we look at the faces here? They don't even show up. There are no UVs for Daisy's hair. And yet, it's not a uniform color either, right? Because when you look at it, it's got this kind of gradient, okay? It's kind of bright up here in the middle, and then it's kind of darker down here, and in the back it's a bit darker, and here it's really dark, right? So how is this working? Well, it's using, this is a material, the hair is using a material that is using vertex colors. And so I think actually I can go back to layout, and I think I could actually mess with it if I go to vertex paint. And I want to kind of, wait, let's get into vertex mode. Why is it highlighted like this? Oh, I'm just editing this, this one face. I want to edit all the vertices. So I could go, I just bit my tongue. I keep doing that today. I'm not sure why. Blue hair, okay? And you can recolor the hair like that. Doesn't look that great, but that's, yeah, that's how it goes. Anyway, cool. So if you don't realize that they're using vertex colors for this particular part of the model, you're going to be very confused. If you bring a model like this into a game engine, you're going to be extremely confused. Because if you bring this particular model, I'll show you a footage of it later. If you bring this model into Unity, she's going to be missing her entire, forehead. Okay? The hair is just gone. Basically, it looks like this. Let's go back to object mode. Yeah, it looks something like that, okay? And the reason is that by default, most game engines do not use vertex coloring, and they're not set up to render it properly. So actually, you have to bring the model into Unity, see that she is missing half of her skull and all of her hair, and you have to go in and program a shader yourself, hook it up so that it will use vertex colors. Then the character comes to life and it all looks much better. One big thing you're going to discover is that 3D models are not very portable. In fact, you've already discovered this. How many of you have tried to import something to Sketchfab and it just looks weird? It's different, right? The materials are broken. Sometimes an object is flat out missing. Sometimes it won't upload at all. You get the error 13, okay? Well, that's because 3D models can have so many things in them. And depending on what program you use, if you use Blender, you can have special things that other modeling programs can't give you. And in Maya, there are special features and tools you can pack into your 3D model that only Maya will understand. Non-standardized features are everywhere in 3D models and in 3D file formats. If you try and upload a .blend file, it's going to have a different structure and support for different properties and features than if you try and upload an FBX versus an OBJ versus, a GLB, okay? It's the Wild West, all right? It is a mess, and some things are portable. Like if you keep your character mainly to using not a mixed shader, but if you use a mission and if you use Principled BSDF, then you have a better chance that things will move over perfectly. Okay, and the other program, whether it's Sketchfab or Unity or Maya or whatever, it will just immediately understand. But if you're doing anything weird or spicy, even in the slightest, okay, if you're getting funky, even a tiny bit, then you are going to get blown up, okay? And you're going to have to go to the other program, and you're going to have to basically kind of fix things up and program the material again. Okay, that's going to happen in Unity in the second half of the course. Okay, you're going to learn how to do that in Unity. It's not too bad. In fact, it looks actually a lot like this. Okay, it's called Shader Graph, and it looks very similar. Unreal Engine also has something very similar to this. But yeah, you're going to have to do that. So anyway, that's my tangent. How did we get on this tangent? Anyone know? Anyone remember? Well, hopefully it was a useful one too. Okay, these problems are going to show up again, and it's an interesting topic. Maybe one day we will have a beautiful universal 3D model format. But today definitely ain't that day. So we're not there, okay? So, all right, good, I'm streaming. Very well done on all of the gallery models, okay? These things are absolutely fantastic. Please remember, we expect you to take 3 days off. And in fact, if you want to get an A- on this assignment, you can take more than 3 days off, okay? That is A-okay, all right? Like, you don't have to get 100% on every assignment in this course, all right? So don't let yourself get burned out. I'll say that this is getting extremely impressive. Sketchfab is kind of struggling. Some of these beds, I know a lot of them used texture mapping. Some of them even managed to get it into Sketchfab, like this one right here. Shristi, this looks fantastic. This reminds me so much of some of the old school computer games I grew up playing. I think this looks absolutely amazing. What a wonderful job. Well done. All of these look absolutely fantastic, okay? A reminder, do not let yourself don't let comparisons steal your joy. Take inspiration from what your teammates are doing, your peers are doing. But remember, like, sometimes they got more time than you. They have a bit more knowledge than you, not because they worked harder or they're smarter, but maybe because they had a little bit more prior experience, okay? And just in general, we all learn at very different speeds, okay? So some things are going to be very natural and fast for you to learn. They're going to be very difficult for most of your peers, okay? So just keep that in mind, and vice versa. This is amazing. You know, the Duderstadt Center director asked me for this directory because she saw how cool these models were. So I can't believe this. No one's going to be able to believe this. I got to include this link on the Duderstadt newsletter. So, yep, hopefully going to have a lot of people taking a look at these models soon. Okay, and remember, 20 minutes. Are you kidding me? These are amazing. Every single one of them are amazing for 20 minutes. Okay, and then some are just crazy good for 20 minutes. And then some of them are not 20 minutes, and they took like 40 or 60. Just be careful, don't burn yourself out, all right? Okay, one interesting topic I saw recently is this question, well, Blender is really on the upswing, and it is. It's a fantastic tool. Hopefully you are starting to develop a fondness for it as some of the friction melts away, as you get more experience, more time with it. But it is an unavoidable fact that Blender is still not a big thing among the big AAA studios. Some of them absolutely use it. It's a great skill to have. They like to see that on your resume. But most companies prefer Maya. And I wanted to explain why that is, but I found a tremendous video I actually want to show you. It's about 8 minutes long, and that kind of goes into why it is. And I'll alliterate a little bit. I'll talk a little bit more about it once we're done. Let's go ahead and take a look at this video. Why do studios ignore Blender? It is actual trash. No, this is just a thumbnail meant to get you to click, and it works. Okay, let's give it a shot.
If you look at the most used 3D software, Blender is by far the most popular. So what is it about it that they don't like? I've been using Blender for 3 years, and it's fast, intuitive, it's got tons of support and add-ons and perfect functionality. So why do you have to spend thousands of dollars on other programs when Blender is so good? Do studios know something about these other programs that the average 3D artist doesn't? Well, the service level answer to this question is really obvious. But if we truly want to understand why studios choose to ignore Blender, we need to dig a little bit deeper. So Blender was first released in 1994, but that was not the Blender that we all know. The open source Blender that everyone uses today was released in 2002. There was a whole ownership battle between the creator and the investors who wanted to keep Blender paid, but eventually the creator won and Blender was made open source. However, when it was released to the public, it was already outclassed by other programs like Maya or 3ds Max that were already being used by professionals. And it was only really in the past few years that Blender has become viable for professional work. That means that during the 2000s, when CGI became cheaper than practical filmmaking for most projects, Blender wasn't even an option. So from 2002 all the way up to 2019, when Blender 2.8 was released, it really wasn't that viable for professional productions at all. It was slow, had no support, and it was difficult to modify with add-ons because all the major add-on and plugin developers were focusing on plugins for the Big Four. So what changed? Why is Blender more viable today than it was back then? And why are studios still choosing to ignore it? So first of all, with Blender 2.8 came a new user interface, which is more friendly to new artists. They improved scene updates, which made Blender more responsive. They added Eevee, Blender's real-time 2D render engine, they added Grease Pencil for 2D animators, and they added the collection system that we all know today. So this update was a huge leap forward. But since then, we've seen other massive updates like Cycles X, Light Linking, and Geometry Nodes, just to name a few. So in the last 5 years, Blender has improved dramatically. And with the improvements to Blender also keeps new support from the community. A massive wave of Blender users that have just picked up the program by watching YouTube tutorials. All of these improvements help people wonder, why do studios still choose to spend thousands of dollars on other programs when Blender is free? To answer that question, I want you to put yourself in the shoes of a visual effects supervisor. You work at a large visual effects house. Let's just say Weta, for example. And you spend $180,000 per year to kit out your team of 100 artists with their choice of Maya, 3ds Max, Cinema 4D, or Houdini, depending on their role in your team. So let's just say that switching to Blender would save you $180,000 per year. It's a no-brainer, right? Well, not at all. According to ZipRecruiter, the average salary of a visual effects artist working in a studio is $105,000 per year. It's just in the US, but let's just roll with it. So let's assume that each person on your team would take 2 full months of full-time work to reach the same expert level of efficiency in Blender they have in their old program. If that were the case, then in just lost time, you would lose $1.765 million, enough to pay for almost 10 years of subscriptions for your whole team. Now, this example makes a whole lot of assumptions, but it just sort of gives you a feel for the sort of considerations these studios have to make. And this doesn't even factor in the most important detail. Blender is worse. Now, Blender being a jack-of-all-trades program means that on an individual level, it is in some ways better than each of these other programs. But when you have Maya for your animation team, 3ds Max for modeling, Maya for simulations, and so on, your efficiency and quality of work is going to just be better than Blender. I say that as a Blender fan. I use Blender for the vast majority of my work, both for freelance and just for YouTube. But at the highest level of production, it's kind of garbage, especially when you consider that studios spend hundreds of millions of dollars on feature films. So what's an extra $100,000 to get the best-in-class visual effects software? So those are some obvious considerations. And they tell us why Blender is not industry standard right now. But the next reason is why Blender will never be industry standard. Also, if you're enjoying the video, you should drop a like. It really helps out. So if you're a studio looking to pick up a Maya subscription for 100 3D artists, you're essentially buying Maya in bulk. You're going to be spending a ton of money, and Autodesk wants to make sure that you're happy so they can keep getting paid. Bulk discounts are everywhere. For instance, I work at a water garden store. If a customer buys an entire roll of pond liner, instead of just a small piece, we give them a 10% discount to try and incentivize them. But we can't really give a much bigger discount than that, because at a certain point, we're just going to be losing money. The more liner we sell, the more money it costs us as well. When Autodesk sells a Maya subscription, it isn't selling a physical product that costs it more the more it sells. It doesn't cost them more to have more users. That means that they can discount however much they need to make sale. Now, obviously, the public does not have access to the business statements of these large visual effects houses. But it wouldn't surprise me at all if Meta had a deal with Autodesk that says, we'll buy Autodesk for all 1,000 of our employees, and we'll do that for the next 10 years, but you have to give us a 50% discount. This is essentially a win-win. Autodesk secures a big client for years to come, and Weta saves millions of dollars. Now, I personally believe this is going on. It is somewhat conjecture. But the next reason is improvement. Large visual effects houses get support. We just talked about why Autodesk would be incentivized to keep Weta happy. They wouldn't want to lose a multi-billion-dollar account. So if Weta has an issue with 3ds Max, they have access to support from the Autodesk team. Now, Autodesk offers support to all of its users. But there have been many cases of individuals who have reported that Autodesk just completely ignores their claims. glance. Yet while Autodesk feels like it can lose one user, it definitely doesn't want to give up servicing an entire company. This creates an even bigger divide. While indie studios and individuals get ignored, these larger studios enjoy the support that everyone was advertised. This is why many small indie studios and individuals choose to opt for Blender rather than dropping the cash on an expensive suite of programs. So after all of that, why do studios hate Blender? They're basically just saying, if it ain't broke, don't fix it. Why would we stop using the programs that are working so well and risk switching over to the unknown Blender? That would be a big risk. Something that large studios in general hate taking. Which is why, even though I love Blender, I don't think it'll become industry standard anytime soon. So Blender is obviously worse for studios who have access to almost infinite resources. I mean, in an interview with Quarter Digital, Kelly Port of Digital Domain, one of the largest visual effects houses, said this.
So at this point, is there like a full perfect 3D construction of New York, like on the servers somewhere at Digital Domain or Disney or something?
I think so. The off-reveal sequence on that bridge, Digital Domain did that sequence, and it's about 4 square miles of fully digital environment.
So obviously, as solo VFX artists, we are at a huge disadvantage. These large studios have access to thousands or even millions of assets. So there is an add-on inside of Blender that's made a huge difference in bridging this gap.
Okay, blah, blah, blah. I think this is the part of the advertising part of the video. I really like this video a lot. I think he's right in many ways. I think he's completely wrong with his second conclusion, right? So in the middle of the video, he states, I'm going to explain to you why Blender will never be industry standard. And then toward the end of the video, he says, well, Blender will never be standard anytime soon, which is not what never means. And the big obvious, thing that makes you wonder about this is, anyone know what happened to the server market? What are most servers? What are the vast majority of servers? What do they run on? Are they Windows? Are they OS X server from Apple? No. Linux, the open source project, won. It took over. It dominates. It completely owns the enterprise server world. And you could also say, what's happening to Unity these days? The Unity company is sweating a little bit. There's this community open source game engine called Godot. And actually, Godot does almost everything Unity can do, except it does it for free. Not quite as fast. There's some bells and whistles that aren't there, but Unity's running out of bells and whistles. Okay? Unreal Engine is eating them on the top end, and Godot is eating them on the low end. And so, who's to say that one day, all of those fancy extra features that Maya is so good at haven't flowed down into the open source products? Okay? And maybe one day, Blender is so stable and so standard, and the community is so good, you don't really want or need the support from the Maya team. Okay? And if you want to buy it, you can do what Linux users currently do. They can hire a company like Red Hat, who are expert in Linux. And you pay them a contract, and they help you out and make customizations for you when you need it. So I really like this video a lot. I think it's a great one and very polished and well done. Good arguments, too, but I don't agree with it. And by the way, keep that in mind when you consume things, right? You can enjoy a really, really good documentary or video. You don't have to necessarily agree with the conclusions. In fact, when someone makes an argument like this, all of these good, high-quality YouTube videos are essays, after all. You should debate the essay in your head. Do you agree? If you don't agree, if you feel like it's wrong, ask yourself why. Can you articulate why? And that will really help you enjoy consuming this kind of stuff much more. Okay, quick fun update. Microsoft Flight Sim, super cool. Very, very big game, if you can call it that. Flight simulator. I saw this the other day. The team said we took the opportunity to tackle some housekeeping, like moving to a new version of their Flight Sim, such as optimizing the meshes of their cockpits, okay? So Microsoft Flight Sim has to render like the entire world around you, especially if you're flying in clear weather, because you need to see a long distance. Trust me, that's just how it is when you're up in the sky, okay? And actually being able to see the cities around you and landmarks is really important for finding the airport. Okay, you don't think it would be as hard as it is, but just finding where you are supposed to land when you are thousands of feet in the sky, way harder than you think. Okay, and actually a huge problem, a very dangerous thing for pilots is landing on the wrong runway or at the wrong airport. They're flying in and they call up the tower, right, air traffic control, right, Cessna, right, 4614 Bravo, 5 miles to your southwest inbound for the option, and you get clearance to come down to that airport and land, and you just land at the wrong airport. You land at an airport like 5 miles away. Very easy at Ann Arbor, where the Ann Arbor airport's not that far from Willow Run Airport in Ypsilanti. So anyway, so we really want to have good performance. We want to have a lot of objects. So that means we need to have low mesh tri-counts. We need to have simple geometry so we can have good performance. So what did they do? They said they replaced the mesh-based welding lines, okay, all this detail, with new meshes that use a normal map for details. A normal map, okay? That is one of those lighting-related maps that we showed you a couple days ago with the coin, right? Remember the super beautiful coin that had very simple geometry, but a beautiful divot in the center? That's what they're doing here. And today we are going to talk about these special types of textures. Maps, they are often called. A normal map is one of the most common and famous and impactful ones. But they were able to get like this piece of geometry. Look at all these nasty, this topology looks really messy too. Get it down from 6,000 to 770. That is massive. Okay, good stuff. If you are interviewing for a game dev job, this is the kind of thing that the interview is going to be really excited if you know this. Okay, like there's one thing to make it look good. In games, we care very much about performance and we care very much about how easy is the model to tweak in the future. It's like writing good code. Okay, good code is not less buggy, it's more performant, and it's much easier to read and understand and build on top of. You're putting together a really good foundation for your building so we can build it really quickly and we can do a great job in the future, okay? Okay, just a thing I noticed, low poly style just seems to be taken over these days, okay? There was a time when if you had a game that looked like this, or a film, they'd say, the game looks awful. It looks old. It's lame, right? Now, people love this style now, right? And they use it for lots of fun art stuff. And if you make an indie game today, if you make a low-poly game that looks like this, people are going to love it, okay? I will also say this next example is a little bit controversial. Maybe you can take this too far, though, because even our cars are starting to kind of... Yeah, this car did not sell that well, I don't think. But, maybe it's not the visuals. Maybe it's some of the other things. We'll see. But anyway, you raised your hand? Yeah.
Yeah. So it's like a whole genre in horror, right? To have the low poly, and Roblox, too, for this.
May I interest you in an indie game hitting the market soon? It's called Greek Tragedy. It is I'm not very good at environments, but I think this kind of looks cool. I think I got a good camera shot on this one, right? This person chasing you back there, kind of angular. This was like 4 years ago, and I was even worse at environments than I am now, okay? Anyway, absolutely. So actually, you could say that low-poly indie survival horror game is like an extremely oversaturated market now, actually. And if you do this, it's going to be like you're just, maybe not a good idea, okay? But yes, you're right. And it's super fun, isn't it?
And a lot of people don't even know what it's called, right? But they like the way it looks. I didn't know.
Yeah, I think people just tend to call it like low poly or retro or lo-fi. Very common. Yeah, it's good stuff. Okay, so I was having a conversation. I talked about this the other day a bit. I was having a conversation with Brent Lattery, okay? And he confirmed this. Now, Brett is... this is the kind of guy you want to be talking to, okay? This is a guy who has 12,000 followers on Twitter. Not too bad, okay? He has some other social media accounts. He's the guy who did the Sonic 3 credits scene, which is really, really cool. And if you look he has an incredibly effective way of making money as an indie artist, okay? And making money, I feel like, is a topic that doesn't get talked about enough in art circles. You cannot make good art if you are starving or you can't keep the power on because you can't pay the bills, okay? You got to pay the bills. So how are you going to pay the bills? Well, here's one way you can do it. There are many other ways. And by the way, I'm not necessarily saying you should do it this way because it's kind of a spicy way. But this is how he does it. Let's take a look, all right? This is Brent Lattery, and if you look carefully at his social media, you can see exactly how he's accomplishing what he accomplishes. He's doing a great job with it. What he does, and what many artists do, is they gain a following by kind of leveraging IP that already exists. Copyright. You're violating copyright, aren't you? Well, you know, it's kind of a gray area in a way. Okay, you're making original works, but using an existing IP, and you're not making money from it. Okay, so is that educational? Is that fair use? It's a little bit wishy-washy, and most companies don't care that much. Okay, Comic Cons are a big thing. Companies don't always go through and raid those Comic Cons. They let people make fan art because they want people to celebrate their characters and all that. It helps the company. So let's take a look here. I'm going to scroll down right here. Look at all those followers. We want that. If you got that, you can make some money. Okay? But look at this right here. Any fans of Spyro? This is an original work using Brent's fantastic 3D low poly art style of Spyro. This is not a character he owns. It's a great character design. This has 1.1 thousand likes. Okay? Super popular. What he did was he made a mock magazine ad for a game that does not exist. This is a Smash Brothers style game, but using all the PlayStation IP. Okay, and so he's hitting it all. He is hitting nostalgia. Okay, he is hitting the Smash Brothers fan base, and he is hitting the fan bases of all these characters. Okay, and as a result, it's extremely popular. It goes viral. People are following him like crazy. Okay, he has big screenshots, okay, that look very convincing. He puts a lot of work into this, okay? We've got Lara Croft, we've got Crash Bandicoot. I'm a huge fan of Crash, so of course I'm big into that. He goes further, right? He actually shows off his Blender scene and how he built all of this and what his techniques are. That gets him a lot of follows from people who are learning, students, all that, okay? Right, more art. He's putting a ton of effort into creating really cool, right, dynamic art using IP that people already care about. People already care about these characters, okay? Now, look what happens next. Look what happens next. He uses these existing IPs and he puts his heart and soul into them to get a lot of followers. And then once he has an audience, watch what he's about to do. Watch this. His top post. This is a game that he made with characters he owns. Let's take a look. There you go. And he made this retro arcade model, right? Get people excited, make a fantastic trailer. That video, even though it's using new original IP, 349 likes. Not too bad. Okay, not too bad at all. So how did the game do? The game releases, and I think I go to Steam and I find it. So if you look this game up on Steam, Hyper Chess, it managed to get, let me see, 181 very positive reviews. Okay, and look at the price, $3. Okay, nice cheap price. How much money did Brent make? Do you know? So let's do a little bit of quick math. Okay, so what did we have? 181 sales. Okay, times, actually those are reviews. So the current estimation, I think, is about 40 genuine sales to every one review. Okay, I think it's actually the number that was found through actual research was like 48 or something. So maybe it's a bit different, but let's try it. So 40, okay, $3, okay, per sale. Revenue, 21 grand. Not too bad, okay? And that is a basic chess game. If you made that game in a month or two, that's not a bad haul, okay? Now, you still have to pay Steam from this money. They take 30%. You have to pay your taxes, okay, from that money. So that's what, another 20%? And then if Brent made this game with a programmer, got to split in half, okay? So chances are Brent is actually, I don't know. Brent, I could actually ask him how correct my math is. Maybe I'll do that later tonight and get back to you. But yeah, probably a few grand, okay? If they're splitting this revenue or profit style, probably a few grand. We'll see. But, right? So this is how you can do it. And now he can just continue to make fan art sometimes, but he can also go make his own original IP, and people actually pay attention to it. I will say, and this is just a personal thing, okay? I'm not trying to, I hope Brent forgives me for saying this. Where's that girl character? This isn't my favorite character design in the world. I think she's really cool, but compare her to Spyro or Lara Croft or Crash, right? I don't think the character design is quite up to that standard, but it doesn't matter, okay? This is a character who probably gets buried if this game just releases on itch.io on Steam. This game disappears, probably no one plays it, okay? But because Brent has this following, his game will be the one that people see. And maybe there are better games out there with cooler characters. They're not going to be seen, okay? They're just buried. Hundreds of games coming out every single day. It's a little depressing, right? But okay, the people who climb to the top of the pile are going to be people who are thinking about some of this stuff and how to build a following over time, okay? Anyway, this is a spicy technique because basically you're using someone else's IP. Is that a legal gray area? Artists like this often get a following, then open a Patreon because now people are paying you not for any particular model, but for your just general work that you do. Okay, and that's a little bit easier, I think, for artists to get away with. And yeah, if it gets big enough, yeah, start selling actual products with your original characters. You have total freedom. Rock and roll. Okay, go for it.
I feel like I've also heard kind of on the fan art side. A lot of major companies, if they like your art, they will scout you, and especially if you show that you are accustomed to their characters, if you know what's happening, if it's something you enjoy. I know, for example, at Leaf Riot Games, for a lot of their things, sometimes if they implement it to the game, the idea comes from fan art. They see the fan art, they see the artists, and they're like, hey, we would like to introduce your style of art into the game this way.
Yeah, absolutely.
Work with them.
Rock and roll. So the company has to be careful about that. So Bungie just got bit by this, where some of their artists that work at Bungie, they saw some art they really liked from an indie artist online, and they just kind of yoinked it and stole it. And oops, because as much as the company can go after the artist for leveraging that copyrighted work, the artist can go after a company that does that too. And the company is a much juicier target than the artist, okay? If that happens, the lawyers are going to be lining up to help you out, okay? On commission, probably. This game is called Sonic Mania. It's a really successful Sonic game that was made by modders, okay? A modding team, Christian Whitehead and some of the other Sonic fan game modding community members made the best Sonic game in a decade when Sega gave them the rights to go and give it a shot. So, yeah, rock and roll. Sometimes it goes really well. Look at that money. All right. Now we're talking. Okay, Very good, all right? And I know this isn't the most pleasant topic for a lot of artists, and I know it may be sometimes in stamps this is not a very popular topic, but I do think it's an important thing to at least think about, okay? So think about it, do the best you can, and there are also other techniques to make it as an artist as well, so don't feel like you have to do something like this. But it is a very common technique these days, and you should know that. Okay, so what I want to do is I want to return to the topic of textures today, okay? And this isn't going to be a super long lecture, but at our previous lecture on Monday, we talked about texture mapping and we saw some textures that were doing some funky stuff, okay? Some really powerful stuff, okay? You remember these coins from Monday, okay? Now, do you remember this coin on the left looks more basic than the coin on the right? And yet, it is the coin on the right that has much more simple geometry than the coin on the left, okay? The question is, well, how can this be? How did they do this, right? This is amazing. It seems like it shouldn't be possible. But actually, it is completely true. And that's because the team moved a lot of their detail out of the geometry and into their texture work. But it's not just visual textures. You remember like the faces we drew for Daisy, okay, on Monday, all right? These are just standard textures, okay? You see the texture, you paste it onto the side of the face, and you're good, okay? Doesn't this look kind of weird? Like, did I delete her head? Is it just flat out gone now? Getting kind of freaked out. There we go, it's back. It's still blue, but it's back. Okay. And so, right, we have these models. This one over here uses geometry for detail. Don't want to do that if you don't have to. And over here on the right, we're using more texture work for detail. This is the ticket. This is what you want in modern days. But the question we didn't really answer was, what kind of textures does this coin use? Because, right, for Daisy's face, we're just using the most standard texture possible. You go into Paint or Photoshop, you draw a face, you put it on the side, right? Those are the images you know and that you love. But today I want to talk about some very special images, some very special textures, okay? I want to talk to you about a texture known as the normal map. Textures known as roughness maps, displacement maps, super special custom maps, okay? These are where it is at, okay? And if you can get a feel for these, you can create beautiful, gorgeous models, okay? In fact, you can do even more than that. You can create some extremely advanced gameplay features that most students have no idea how to implement, okay? So I want to talk to you about these strange kind of maps, okay? When you look at this for the first time, do you remember the first time you saw a weird texture like this? Maybe the first time was in this class. You're like, what on earth is this pink coin, right? It's like blue and pink and red and green, and it looks weird, right? And yet, you can still kind of see the shape of the coin in here. In fact, you can see it really well. This is clearly a coin. It's just colored in a very strange way. What is going on, okay? When you look at these textures, you will, by default, want to interpret them. Your brain will want to see them as any other image. But you have to fight that because these are not normal images. These are special textures, okay? These are not like any image that you're used to looking at or that you've ever seen, okay? Here is a typical pleasant image that you might just see online, okay? A gameplay screenshot. You can see some snow, okay, a blocky environment. You can see an adorable woodchuck, okay, a groundhog. It looks like just a normal image, right? Your brain can interpret it and see what's inside. This is not an image you are used to seeing. This is a strange image that has no meaning to you. It's not very pleasant to look at, okay? And yet, it is so exceptionally important. Do you know what this image is to the right? Because I've got a spoiler for you. This image on the right, you're seeing it on the left too. What is this image on the right? Can you tell me right now what this actually is? This texture on the right. Yes?
Is it the path that it goes in?
This is what we call the snow map. Okay? This is a special texture. Okay? A very, very special texture that is critical for the gameplay and the visuals and feel of this particular snowy game. Okay? In this game, you can see it moving right now. This is a game called Goodbye Groundhog that I made in 2021 for a quick game jam. I made this in, I think, a week or so. And I knew I wanted to make a game that, we were playing as some animals during the winter. In the game's narrative, the winter has never ended. It has continued to go on forever, and the animal kingdom is starting to freak out and figure out who to blame for this. And they end up blaming the groundhogs. You're a groundhog, that's a bit of a problem, okay? And so anyway, this was going to be a game set up in the mountains during a very snowy winter. And so I knew that if I had nothing else in my game, I had to have excellent snow, okay? Otherwise, this is hardly a winter game. Imagine creating a winter game with bad snow. Ridiculous, right? And so, with the very finite amount of time that I had, I wanted to create good snow. Well, how do you create snow that morphs and crumples as you move through it? It melts as you progress. How do you do it? How do you even start? Well, here's a way you can start to think about it, okay? Here's what we're going to do. As a character, as a unit walks through the environment, we're actually going to mark down where the unit has walked. And what's a good way to mark down where the character has walked? What about drawing to a texture? In this game, as you walk around, the game is constantly drawing onto a 2D texture. You can't see it, but actually, if you look, you can find it on the desktop. It's hidden in the applications folder, right? And this is called the snow map, okay? Now, why is this red? Well, the only thing we care about in this texture is keeping track of where you are, and in particular, where's the snow melted through and where's the snow thick and luscious, okay? In other words, we only need one channel of our pixels. Do you know how pixels are usually represented? On a screen or often in a file as well, like a BMP file, PNG, RGB. Sometimes A too, if you've got an alpha channel, right? A transparent image like you see in a PNG or a GIF. RGB, okay, red, green, blue. And these channels are, we don't need the green or the blue. We're just going to use the red. And the red, the more red the pixel is, the more melted the snow is. Okay? From 0 to 255, every pixel tells us how melty the snow is right there. And what we're going to do is we're going to use the snow map, right? The snow map. Okay. A large texture image. The black pixels mean there's lots of snow. The red pixels mean it's melted all the way through. What does a partially red pixel mean? Anyone know? Yes?
Melting.
It's kind of like half melted, right? So like you got snow up here. The pixels that are fully black are full snow, big snowbank. The ones that are fully red are the ones you've walked through and fully melted to the ground. And the other pixels, which are kind of fuzzy, are like, it's kind of sort of melted, right? So this gives you that beautiful, right, little partial melt. It's like a tunnel you're carving through the snow. We only use the R channel, which is why it is red only, okay? It's strange. Wait, why didn't we use white? Well, it's a snow map, so you'd think we'd use white, but actually we don't need that much data, okay? If we want to have a white color here, we need to use RGB, all of those channels, and that's going to, triple the size of our texture. We don't need that, okay? We're going to be efficient, okay? And so it's going to save us memory, all right? And so when you look through this, you can see this beautiful effect, right? Where the snow kind of alongside you is only partially melted, so you've got this kind of bowl you're cutting, right? And so that's how we make this work. As a character walks around, the game code is drawing to the snow map, the same way that you would in something like Photoshop or GIMP. Do you see this? It's doing this, okay? And it's doing this for every character. One really cool thing, some of the maps have snowfall. So every frame, the red pixels get slightly darker until the snow has fully risen back, okay? And that creates a really nice effect where you could walk through a path and then a few moments later the path has filled with snow again, okay? Just beautiful. So we're drawing to this texture constantly. And meanwhile, a high vertex cube uses a special material to raise and lower the vertices based on what it sees at that location in the map, okay? So something like this. We have a super high vertex cube, and these vertices have a custom shader, okay? In that shading tab, a bunch of custom nodes that cause the vertex to be higher if you have the black pixel and lower if you have the more red pixel, okay? And so, as a result, you get this really interesting, beautiful, unique look to your game and your gameplay. This is actually a tower defense style game. It's in that genre. And the cool thing about this is that when enemies are pouring out of the gates and rushing for you, and when your turrets you've set up are shooting, you get this wonderful sense of movement because the enemies are kind of showing you their path they're taking to get you, and the projectiles are carving a path through the snow, so you have this incredible sense of battle that is going on, right? This is the kind of thing you can do if you understand what is happening under the hood and you can wield these special textures, okay? Students can almost never do this, which is why student games, the moment you put something like this in your game, it no longer looks like a student game, does it? There are some things that look crappy, like the walls here look terrible, but not too bad, yeah? Here's the takeaway. This long tangent, okay? The takeaway is this. Textures can be more than pretty pictures, okay? They can be more than just simple expressions that you slap onto a character's face to make them have a goofy face, okay? They can be more than that. They can be that, but they can be more than that too. Textures can be used for special effects, okay? And textures can hold extremely important information that might not look good to your eyes, but are extremely important to your game and your experience, okay? And so I want to show you a clip from Halo, all right? If you've gotten far in the homework, you might have already seen this. I'm going to show you this clip. I keep biting my tongue. That's like the fourth time today. What's going on? My teeth are growing or something. Okay, a quick aside. I actually had a mutant superpower. Can you guess what it is? It relates to teeth. So I was born with 2 extra teeth in my jaw, right here, like in my chin. So they just chilled there for most of my life. You know, maybe I need a spare one day. Not too bad, right? And they're just fine. No big deal at all. They started coming in a few years ago. And they're like in my jaw. So I have these teeth that are deeper in my jaw. Maybe it could give me like a combat buff, an advantage in a fight or something. I use the bite attack, just rip my opponent to shreds, right? Or maybe, you know, that kind of like evolutionary thingy mabobber mutation. I don't know, maybe like, I think some animals have like extra teeth to help process food or something, or help like snap bones or really things that other animals can't eat. I don't know. Anyway, just kind of fun. They started coming up through my jaw and they started interfering with my actual normal teeth. And so they had to get rid of them. So anyway. Yeah, anyway, so that's my story. How did I get there? Did someone bring up teeth?
You kept on biting your tongue.
Oh, I bit my tongue. Yes. Okay. There we go. That's a good segue. Okay. So in Halo, we have a big team of artists, and those artists have incredible ideas in their head. They're going to create the most beautiful environments, okay? But they need tools to help them do this. What is one of the best tools you can hand to an artist? They are so good with this kind of tool. How about a painting program?
I was going to say a pencil.
A pencil? Yes. How about a digital one? Okay? In Halo, the team wanted to have excellent water. Okay? This game is going to have streams. It's going to have pools. It's going to have like an ocean. And the artists need tools to help them define what the water is going to be. What shape is the water going to be? How deep is the water going to be? I want you to watch this very carefully. And I want you to watch, in particular, they're going to show you like 3 seconds of a tool the artist is using to draw the water. And it's awesome, okay? It's like only 3 seconds, but those are 3 good seconds, okay? Let's watch.
Our water shader is pretty highly customizable. The artist can change the murkiness, and you also can change the color of the water. You can change the transparency and sharpness of the wave.
We also have ways for them to paint different parts of the water parameters.
And then the engineer looks at it and goes, oh wow, I never thought you'd be doing something like that with my system. But that's so cool that I want to make a better system for you to do that. And nobody was going to turn out like. And then when it came time for the beta, when it really came together, it was awesome.
Pretty soon, these shows have an area. So basically, you have something cool to actually go out of their ways, making sure that the technology is used in the right way. But do more of a partnership than a competition. Because everybody wants to develop the best.
Halo, right from the start, has always been a game about shooting people and having fun.
Every different type of gameplay interaction Halo needs to be a specific damage system. Damage is kind of one of the base layers of communication between all objects.
Okay, I think that's enough. So, but you can see it, right? Did you see it? So it was just a few seconds, but this was footage of an artist. You can even see their paintbrush right here where their cursor is. And I think right here, it is showing the artist painting depth into a body of water. So basically, you've got like a lot of deepness in the water in these 2 parts, right? Where it kind of drops off. And then this is just generally kind of where the water is, okay? And so this is very, very common thing. On big teams, and this is for films as well as games, you'll often find that the artists are drawing very strange, unpleasant-looking images that actually feed into something incredible. In this case, this texture is a piece of data that stores water depth, and it's fed into the game engine, like into Unity or something. They didn't use Unity, and then the game engine uses it to control how deep things are, okay? And so, yeah, isn't that just strange? It's like you're using Photoshop to change an entire world by just painting a few colors differently, right? It just blows my mind. We're using an image editing program to decide how deep the water will be. Absolutely crazy. What about things like visibility? Does anyone play Civ? Anyone play an RTS games? StarCraft, okay? Warcraft, stuff like that. Well, often in games, you want to know where your characters are. And then anything else in the game won't be visible. You can't see your opponent unless you have your characters, your units, over there to scout them, okay? Things that are just off the edge of the map, shrouded in a fog of war, okay? So this is something we actually just implemented like last year, okay? Sean, I think you know where I'm going with this, right? Yeah. So did you work on this one in particular, the visibility map?
No, I think it was Daniel.
Yeah, I think it was Daniel as well. So this is a kind of RTS game engine that we're chipping away at in the background on a tiny research team. And it's hard to see, but you can see here that when one of your characters kind of walks around the environment, you can see that the environment that was shrouded in this darkness gets lifted. And you can now see what's more, enemy opposing characters, enemy characters that are invisible, they become visible once you walk over there, okay? So this is called a visibility map, and it works the same way as the snow map. As you walk around, you are drawing to a texture, and that texture is used by every character. Every game object has a material on it that is reading that texture all the time and deciding whether it should be visible or not, okay? And so we're using texture to store where can our characters see. And this works for multiple characters, and it's just a great time. Okay, super cool stuff. Again, you don't see any student projects with this kind of tech. Okay, we really got to change that. All right. For the engineering nerds, All right, a really quick aside, okay? And our art nerds might appreciate this as well. I want you to tell me what this is. Engineering nerds, tell me what this is right now, okay? This very moment. Yes? Yeah, it's a 2D array. It's a 2D array of numbers. It is a 2D array of data, okay? So, Jose, right, I want you to tell me now this next one. So this is a 2D array of data, okay? Now tell me what this is.
It's still a 2D array.
It's a 2D array of data, exactly. Okay, it just looks a little bit different, all right? In fact, when you have 2D arrays of data, one of the best ways you can help humans understand what that data is by rendering it as an image, okay? So, the next time you all look at a texture, I don't want you to see just a pretty photo or a picture, okay? I want you to see a grid, okay? A gigantic grid of numbers, okay? And those numbers mean important things. Like in this case, where's there snow and where's there not snow, okay? It is a 2D array and they are fantastic, okay? They are sick. So we are halfway through our lecture. In fact, we're more than halfway through, but we're halfway through our time. So what I want to do is I want to take a 5-minute break. Then we're going to come back with some things that are directly applicable to your Blender work, okay? It's going to make your models look much better, okay? So we're going to come back in 5 minutes. We're going to talk about some very common special types of textures, some very common maps, okay? See you in 5 minutes.
I do change. I felt it. Not because I feel like he's supposed to have a green, but I can't do it.
Just do a bunch of random scribbles on maybe across the page.
Okay. Ladies, gentlemen, everyone. Okay, let's get back to it. So, 2D textures. They can be beautiful images. They can be things you understand intuitively as a human just by looking at them, right? Or they can be these really abstract, strange containers of data. That data could be for anything, for snow maps, for marking where things are visible and where they're not. It could be for anything. So, given that textures can be anything we could ever want them to be, well, what is common? What do people usually use strange textures to do? Okay? One really, really common map, okay? Well, actually, there are quite a few common maps. In fact, if you go online to a big repository of materials, you remember what one we used on Monday? It's a really good one. It's called Ambient CG. Okay, strange name. But ambientcg.com, if you go there, you can look up any material you want. In fact, I'm going to look up rocks. And I type in rocks and I find this really nice material. Okay, this looks amazing. In fact, I'm not sure how they got it to look this good because I wasn't able to get mine to look this good, but I was able to get kind of close. Okay, sort of kind of close. When you download this material, you're going to be super excited, okay? Because now your objects are going to look like this. This is going to be amazing, right? Well, you're going to click on one of these buttons, and it's going to download a zip file for you. And that might be surprising. When you open up the zip file, you are going to see that, wait a second, there's not just one image in here. there's not just one texture that you map onto the mesh, right? There are many textures. There are a lot of images in here, and many of them are very strange, okay? So you can see these really crazy, like pink and blue and green textures, okay? You can see other ones that look like grayscale, but they're kind of different. They have a different feel. This one's like a weird watercolor grayscale. This one's like very choppy, okay? And like grainy, right? And then we can see finally one that actually makes some sense to us. This is called ROX002, 2K resolution, JPG format, color. Okay, this is our color, okay, our albedo, all right? We zoom in on it. This is the least weird texture we are going to see, okay? And so this is probably the first texture you want to add to your mesh, okay? And we're going to actually do that. Okay, we do that the same way we did any other object. We did the brick house with the window on Monday, okay? And look at that. Doesn't that look amazing? And you're kind of like, I kind of thought it would look better. Well, why does it look bad? Okay, like, are you getting it? It's not what I was hoping for, okay? So what went wrong? All right, well, nothing really went wrong. We have only taken the color data from our material. Okay, when you look at these rocks, they have color information on them. But actually, if you look very closely at these rocks, there's also some interesting things related to shadows and light and how light is bouncing around these rocks, okay? And we've got none of that over here. In fact, you know what this looks like? This looks like a cheap plastic ball you would like buy for a child. And it just happens to have like a really crappy plastic, rock texture, melted onto it. Okay, this is like a ball you're gonna buy for like $7 discount at Walmart, I think, or Myers or something. Okay, and so we would really like to keep going, but the good news is that we have a lot of ways to keep going because, all right. Because remember all those other textures. All those other textures. These are the key, okay, to making a really good-looking material. So we need to talk about the next texture in that bundle. This is maybe the most important one after the color, okay? This one right here, okay? This is called the normal map, okay? A normal texture. Now, by normal, I don't mean standard, okay? What does normal mean? So normal means that something is very ordinary or typical or standard. But in a mathematical context, what does normal mean?
Is it in the vector that's perpendicular to the surface?
Bingo, a normal vector. That's right. We're going to talk a little bit more about why that matters in a moment. But when you download something like this, you might see a pink and blue and green texture that's almost always your normal map. And in this case, we actually have two of them. Why? Anyone know? There is no standard for the format of a normal map and how it represents things. This other map, if you can see, this says normal GL. For my engineering nerds, right? This is normal for OpenGL-based rendering systems. This is the normal texture you use if you're using a DirectX Microsoft-powered rendering system. Blender is an open source program, so no surprise, it uses OpenGL instead. Okay, so this is the texture we actually want. But this one over here is the exact same, except the green channel, which is the one that holds your y-axis, is flipped. Okay, don't worry about what that means. Okay, I'll explain it in just a moment. But here it is. See it? Okay, it's kind of like psychedelic a little bit. Like this kind of a 70s style of image, I feel like. And it's very unnatural, okay? This is clearly a texture that doesn't contain things for our human eyes. This is a texture that is storing important data for something. And the question for you is, what is the data encoded in these pixels meant to do? What does it help us with? Okay? What is it for? I'm going to darken this just so we can actually see things in front of it. So I'm darkening it. Each pixel in this image, just like any other image, each pixel has an R, a G, and a B. Red, green, and blue. And red, green, and blue values, these are channels, right? Red can be 0 to 255. If it's 0, there's no red. If it's 255, there's lots of red. Same thing with green, same thing with blue, okay? Each pixel has RGB, all right? And these stand for the red, green, and blue channels, those colors, right? Combine them, mix these three colors, you can get any color you really want, okay? Each pixel stores and has RGB, but each pixel means something different, okay? Each pixel means not RGB, red, green, blue, but X, Y, Z, okay? When you see red, green, and blue on a given pixel, you're actually looking at a vector, a 3D vector that has an X component, a Y component, vertical component, and a Z component. The Z is usually like into the screen, okay? But each one of these pixels has an associated 3D vector. Some are pointing up, some are pointing over there, some are pointing over here, some are pointing down, okay? Isn't that crazy to think about? Each and every pixel, okay? And so we're storing all of these vectors. If you've forgotten what a vector is, we're not talking about C++ vectors for my engineering nerds. We're talking about the mathematical, basically it's an arrow, right? It is a 3D point, X, Y, Z, all right? In this case, it's used as a direction and not a position, okay? All right, so we got X, Y, Z. What does that mean? If you look at this cube right here, this cube has a little indent. Like most of the cube has a normal vector that's kind of pointing out this way. But this cube has a little indent right here. Do you see it? Or this little bowl shape. So that texture would be storing, okay, a R, okay, and a red value on the pixel, a green value on the pixel, and a blue value on the pixel. Now these are not red, green, and blue. These are actually X, Y, and Z. And taking them all, you get a 3D vector like this, okay? This is the final normal vector that shows you kind of what the surface of the shape is, or what it's supposed to be, okay? If it's a little bowl, if we zoomed in on this little divot, you'd expect to see a bunch of normal vectors kind of going in like a bowl shape, okay? And so this is what a normal map is. It's a texture that stores basically surface-related data, okay? Angles coming out of the surface of your object, okay? Now, what are normals? Wikipedia has a really, really great little image here that makes it really clear what a normal is if it's getting a bit too mathy for you, okay? So you've got all these faces, and each face, and some of the vertices too, actually, but each face in this case has a vector, an arrow, coming out of it, okay? And they always come out perfectly perpendicular to the surface. Why does this matter? Does anyone know why we even want these? These arrows are kind of cool, right? But like, they're pointless. Why do we even care? All these normals, all these arrows that you see right here, we're gonna pack them into a texture, and then we're gonna use that texture for something, but who cares? Well, we just wanna make like a really funky 70s style, like hallucinogen looking texture for fun? What can we do with something like this? Any ideas? Yes?
Yeah, I just watched a video about it.
Okay.
I don't know, like, I forget the exact name. But
yes.
They kind of, for example, if you build a wall and there were some patterns on it, you can just put this kind of material on it to show like how they will affect the light.
Bingo.
Yeah.
Yeah, absolutely.
So you don't need to build out the pattern, but you have this
yes.
on it to reflect the light.
Yes, absolutely. Absolutely. I'm looking for an example around the room, but everything is flat down. Yes, you're absolutely right. Okay, this deals with lighting. This texture is going to control how lighting affects the surface of the model, how it bounces off the model. And if that seems pointless, actually, the way that lighting hits a wall is extraordinarily important to understanding its shape, okay? I want you to look at this right now, okay? How do you know this is a 3D cube? How do you know? Yes?
All the different values, which are lighter or darker or medium.
Exactly. So this side, this face of our cube, is shaded a bit differently than this face, which is shaded a bit differently than this face. The lighting, how the light hits and reflects off the surface of an object tells you everything about the shape of that object. Okay? Well, maybe not everything, but a lot of things. Okay? Want me to prove it to you? I'm going to take this away. Okay? I'm going to take this away from you, and we'll see how you do. I'm going to do it by going to emission. Okay? And, okay. Can you tell me what shape this is? Just say it. Just a rhetorical question. Because I'm about to mess with you in just a second, by the way. Hey, it's a cube. Good job. All right. Let's have some fun. Okay. Tell me what shape this is. It is not a cube. It looks like a cube from the silhouette, but the silhouette does not tell you everything, right? So if you want to know what shape this actually is, right, you either have to cheat and go into edit mode, right? Or, right, you need to get your reflections back. You need to get your light working like normal again. This is like cartoon lighting, where suddenly the normals don't matter anymore, okay? The way that light reflects off any face is just always the same. So we're going to go back to our Principle B SDF realistic lighting, and now, right, the light is kind of bright in here. There you go. Now can you tell me what shape it is? Absolutely, right? It is a cube with a strange little extrusion out the side. But the only reason you can fully understand this shape and this object is because the normals are working. The normals are allowing the light coming down to properly reflect off these surfaces in different ways, okay? These surfaces that are facing upward get full brightness. This one on the side gets reduced brightness. This one over here gets almost no brightness, okay? The light source is probably on the other side. Okay, yeah, it is on the other side. It's right here. Okay. So, let's keep looking here. Let's keep looking. Normals, just to recap, are an extremely important thing for computing lighting and how a shape looks and how light reflects off of it. It is a vector, a 3D point, a 3D direction, right, little arrow, that points out of each face, okay? And it helps us understand how light should reflect off of it. Note the curves. So as it gets curvy here, you've got these arrows starting to kind of bend and point in a different direction. That affects the lighting. That's why the shading is a bit different on these beautiful curves, okay? So, you're right, a reminder, these vectors are 3D, so they have X, Y, Z. And we can pack them into the R, G, and B pixels of an image, okay? Why do we care? We kind of went by it already, but mainly it's because of lighting, okay? So if we have an image here, okay, if we have a shape right here, and we have our sun over here, this is our light source, okay? We have our light source, so we have rays kind of coming in this direction. Can you tell me which sides are going to be the brightest? Okay, yes?
The ones facing the light?
Yeah, the ones facing the light, so long as you can see them, okay? Because you can imagine we could be looking with our camera right here on the other side of the object, right? And then, actually, what would you shade the faces over here if our camera is over here?
You can't see them.
You wouldn't shade them at all, right? Exactly. So that does matter. So which faces will be brightest, right? We strongly suspect the ones over here will be brightest. And I won't show you the equation. You can actually use the dot product operation in math along with an equation to take these normals coming out of these faces. Here they're coming out of the vertices, but pretend they're the faces. And you can actually use these normals in addition to the light heading to it and then to your camera to calculate how bright it should be. Okay, and if you do that calculation, right, that's what our hardcore graphics programmers will program for us, okay, you get an object that ends up rendering like this, okay? And so there you are, right? If we have the normals, we can calculate really good lights and lighting, okay? So here's what we can do. We can store all of this normal data in a texture. If we store all of this detail in the texture, where do we not have to put it? We put all this lighting stuff in the texture. We put the texture over a very simple object. Thus, we don't need to put that detail and that lighting information into the geometry. Bingo. Absolutely. Rock and roll. Good, good. Okay? This is how we're going to get crazy cool objects with pretty low vertex counts. Very simple geometry. Okay? So here's a demo of how you can apply this in Blender. And I'll tell you, like, I'm not very good at it. Okay, I think probably a professional 3D artist, because this is your like weekly reminder, I'm an engineer by trade. Okay? It's kind of pressed into this job, I feel like. Okay, what do I do in teaching an art course? Well, hopefully it's not going too poorly for you. Let's take a look, okay? And you can actually experiment. Here we got our plastic, like $7 Walmart ball, beach ball, okay? And it doesn't look very good. The only map, the only texture we've got going on is that color texture. Sometimes the color texture is called albedo, okay? Anyway, I can kind of move it around, but the lighting just doesn't look that good, okay? I can rotate my sun, look at how the lighting changes on our beach ball here. It just looks very plasticky. Not convinced, actually. I'm not convinced at all. So I'm going to go into shading, and you can see here, we only have our color texture being pushed into the base color node. That's the only texture we're using. We've got our principled BSDF, our very realistic shader node right here. This shader node has a lot of other slots that aren't being used. One of those is that little purple normal slot. Okay, that's looking like a really good one. What we can do, Shift A, okay? Shift A, and we can start typing, just go for a texture. I want an image texture, so I'll type image texture. We can now get a second image texture node, okay? The first one is up here with the color texture, but I want this other texture, normal GL, the normal map, okay? Here's a quick tip for all my Windows users. Have a Finder window open, just click in the address bar, copy. You now have that address. Whenever you open up a Blender thing, I really don't like how Blender does this. You can just paste it in, hit enter, and you're right where you want to be. Grab the right file. I hate navigating the Blender dialog, the file dialog. I don't like it at all. Anyway, we now have this texture. You can click on this node and you can see it right here. Just as crazy as you remember it, okay? And now what we're going to do, we're not going to plug it in right away because we actually need to process it a little bit. So I'm going to drag and drop it there. We need to have the normal map node, which I think does some tweaking to the actual texture, like gets it ready to be a normal map. And then we can actually make it stronger or weaker if we want. We got some options. We can plug it in right here and look at that, okay? Like it's not even set up right yet. And it looks 1,000 times better. Look at this. Watch this. Ready? 3, 2, 1. Ooh. Oh, yeah. All right. Not too bad. Okay. And it's actually, this is terrible up here, but it looks way better. So go to color space, and you want to tell Blender that this is not a normal texture. This is a non-color texture. It's like a data texture, really. And Blender treats it a bit differently. I couldn't tell you exactly what it does, but it does make it look quite a bit better. You can adjust the strength to magnify the effect and make it look more 3D, okay? Because light is reacting much more realistically to what we see in the texture, it has this 3D look to it. The ball looks very 3D, despite still just being, look at how beautiful this is, right? As the lights kind of rotate around and move around the ball. It looks really convincing all of a sudden, okay? The light is hitting the flat surface of our ball, but because of the normal map, the light is kind of bouncing in ways you'd expect from a really advanced, really detailed bit of geometry. But this is just a normal UV sphere, okay? Nothing fancy or expensive about it. I guess UV spheres do have quite a bit of vertices by default, but yeah, not too bad, right? So anyway, looks pretty good. So that's already a huge improvement, okay? And it didn't take much time to set up at all. A few things you got to remember. If you're setting up one of these textures and you forget what to do, or you can't get it to look good just out of like 6 or something that we were given. So we've gone from this right here, which is like the plastic beach ball, to this, okay? The lighting is a little bit different than it is over here, and like our rocks are much bigger over here, so we may need to scale the UVs, but it's better. You know, better, still not great though, okay? So let's look at some of the other textures that we were given, okay? Here we go. This is called a displacement texture, okay? Displacement right here, right in the name. Okay, and it looks like this. I think it looks kind of beautiful. It looks like kind of a watercolor painting. A lot of these textures are actually generated. They're not painted by hand. They're generated via special cameras and equipment. So a team will go out and find a bunch of rocks in real life. They'll take the rock, they'll bring the rocks in, they'll scan it with a bunch of different sensors to build these textures, okay? And figure out how high things are, figure out how light reflects off of them, and then precisely turn them into these 2D maps. Okay, these are grayscale images. The displacement map doesn't use RGB. It just kind of is grayscale. So it's just encoding height, okay? Just encoding height. So how far away from the normal surface should we move the object, okay? Should we move the vertices? This is kind of what we're doing with the snow map, because the snow map causes the vertices to go up or down. Likewise, this is going to cause our vertices to go out or in along that normal, okay? And so this is sort of a displacement map right here, the snow map, okay? On your homework, you're going to do something really cool. One of the later problems, it has you take a simple plane, and it says, please use this displacement texture. Actually, you end up drawing this yourself in an image editor. Have any of you done this one? Oh, did you post the final result into Discord? Not yet. I'm so excited because they look awesome, don't they? So, you draw this little displacement, and then when you apply it to the plane, this is what happens. Do you see it? So you go from a flat plane to, oh, that's kind of cool, isn't it? You can see a bit of a shape. Can you see the shape, right? Can you see this really high kind of mountain area in the texture, right? Or in the mesh, right? And on the west side, we have this huge mountain range over here. And in the middle, we kind of have this flat valley, kind of goes around, right? Like that. Pretty awesome. This is what a displacement texture will do, a displacement map. Okay, you can actually, and in fact, I think Unity does this. If you ever use the terrain tool in Unity or Unreal, I think it, when you raise the elevation or lower the elevation, you are drawing, under the hood, you are drawing to a texture like this, okay? And that's causing vertices to go up or down. If you then take this kind of plasticky looking little, bit of environment art, and you add in a color texture, an albedo texture, right? You get something that looks like this. And it's like, oh, this doesn't look bad. This looks pretty cool, doesn't it? For the amount of effort you put in on this problem, I think this actually looks kind of beautiful. The only thing I wish I had done is I wish I had gotten like the orbit, the 3D cam, like you do with the characters, so you could see all the angles of the map. But that's okay. So you'll be making something like this, except you'll get to draw your own environment on the homework, okay? Don't worry, lots of videos on the homework to help you kind of walk you through what to do and all that good stuff. Let's hook this displacement map up in Blender, okay? Not too complicated, pretty similar to the previous one. But one thing you do need to take care of is that by default, we cannot use a texture to alter the geometry, okay? You need to go in to the material and you need to change the settings for displacement. Displacement needs to go from bump only. Bump only refers to like lighting. It's only going to affect the lighting. To bump and displacement. This allows you to actually move the vertices around physically in 3D space by plugging in a texture into the material. If you look around here, there are no obvious slots to plug in a displacement or a height map. Sometimes it's called a height map, by the way. Over here, though, in the material output, we do have a displacement slot. So this is where we're going to plug it in. And just like last time, we're going to create an image texture node. By the way, a really cool thing, you can actually drag in a texture from Finder or Windows Explorer. If you drag it into this window, it'll create a texture node, boom, right there for you, way faster, okay? Anyway, we're going to grab that material that we want. Where is it? Okay, we're going to grab that slot. Going to open it up. That's the one we want, displacement, right? Cool little watercolor, okay? Then we are going to, wait a second. Oh, I jumped way far ahead for some reason. Okay, we're going to plug that into a displacement node, okay? And then that displacement node can go into the displacement output slot, which will actually affect the model. You can mess around with some of these settings. You can magnify the actual result, okay? Watch how it changes. It didn't change very much, but I can actually click on the scale to have it take more and more effect. So do you see how the outside of the object is starting to get a bit more rocky, okay? I don't know if I really like how this looks. I think I like how it looks when it's less scaled, but look at that monstrosity, okay? Ugh. Okay, so anyway, a little bit of roughness. The effect is kind of subtle, all right? Not nearly as important as the normal map, okay? But you can try plugging in the normal map to here. You might get a better result, maybe. But look at this kind of organic shape. It looks more like a meteorite or something now. It's a big chunk of rock, okay? If you look really carefully, you can actually see, right, that underneath it is just a ball. But now it looks quite different, okay? The geometry is much more rough, and we can continue to kind of coax the ball and make whatever shape that we want. It's just going to be a much more rough shape, okay? A little bit more gnarly, a little bit more gritty, which might be what we want, okay? So we've gone from this, which is getting better, to something like this, right? I still can't decide if I like this more or not, actually. Maybe I hooked it up wrong, but it's kind of interesting to look at the very least. We're getting maybe a little bit closer. Probably one of the final big things we can do is try out subdivision and try out some UV manipulation, okay? So I'm going to go into the UVs, and we got a lot of vertices, okay? Probably more than we need, actually. But I'm going to take these UVs. I'm going to select all the faces. Now over here, I can grab the UVs and I can start scaling them. I'm going to turn off our little gizmo visualization. And look at this. Isn't this cool? As I make the UVs smaller and bigger and smaller and bigger, we're getting this really nice kind of really chippy outcropping of rocks. I think this actually looks really good. And this is kind of what we see in that image that we're aiming for, the goal image, right? The goal image over here has a lot of tiny rocks. We had a lot of big rocks. And when we kind of scale the UVs, we get something a lot closer, okay? Now the last thing here, right? You know, this isn't quite as good. We didn't quite make it all the way there, but it's much better than it was, okay? And actually, I think one really big thing is that the lighting in this scene is using like studio lighting with a professional film renderer. It's probably using the Cycles renderer instead of the EV renderer, which we're currently using. This is a real-time render. This is a serious, deluxe. Like, we're going to take 30 seconds to render the frame renderer, okay? And so I think that's why it's still a little bit different, okay? If you want to go to that super deluxe render, do you know how to do it? Anyone? So actually, you go up to this little render options, render properties, and you click render engine. You want to go from EV to Cycles, okay? This will make everything much slower, like wildly slower, actually. I'm rotating the camera, and it can't even keep up, okay? That's how much slower it is. This is what you would do for a film. And EV is much more of a game style, interactive, real-time, 60 frames per second kind of render, okay? And so that's something to note. If you can't achieve the results you're seeing online, you might be using just flat out the wrong settings in Blender, okay? That can happen, all right? So anyway, the main takeaway here today is that textures, 2D images, can be beautiful photos that we're used to every day of our life. We see them, okay? We see them on posters, we see them in images or selfies, okay? But they can also be anything. They can be arbitrary containers of data, usually 2D grid data, okay? Which is why images are so good at helping us visualize them and understand them. But advanced games will use a ton of textures just to store interesting information, like the visibility map, like normals, okay, like displacement, terrain. Games that have beautiful terrain will often have a height map, which is just a super big texture where the pixels tell you how high the cliff is, right, or how low the valley is, okay? And in Blender, you can spend a lot of time in this awesome little shading tab, and you can start plugging things in however you want. You can do Shift-A, and you can actually find many different things you can plug in, not just an image. And as you do this, the way that your objects are rendered, the way that they look will change. In many cases, they become dramatically more detailed, okay? Do you know what this style of material is called? This is kind of a modern innovation. Like the last few decades, these materials started to show up. This is called physically based rendering, PBR materials, okay? These are materials that go very hard to recreate realism perfectly. And you can see from here, if you set things up right, get all the right settings in Blender or Maya or 3ds Max, that looks good, right? That looks really good. Okay, almost like photorealistic. So this is called PBR, and it's becoming more and more common. Okay, does anyone have any questions or comments about any of this? Okay, yes.
So that block that you showed us, what was it? The
Block.
first one was the block in the menu with all the lower menu.
Lower
You're
menu.
connecting the normals and.
Oh. Here, like here?
Okay, yeah.
This little area.
Displacement block. I noticed that it.
Yep.
You talked about how it had both displacement and normal. Why does the displacement block have a separate normal, setting than the other things?
I don't know. So, what I think, when it comes to displacement, it used to be the case that displacement maps were actually mostly called bump maps. And it's mainly, they were called bump maps because you would tell the render kind of how high something was on a material, on a texture. And that wasn't used to move any physical vertices. That was only used for the lighting, okay? Because today we use a lot of normal maps, and that encodes the 3 directions, right? But actually, you don't need that. If you just know the height of something, you can kind of calculate, right, the slope that goes up to that height, right, by just looking at the height and kind of doing an interpolation. So I think it relates to that, and I think the node has a normal slot to basically say, hey, do you want to override that? And plug in your own normals so we don't calculate our own. So I think that's probably what's happening, but I don't know for sure, right? This is not my wheelhouse, and no one is ever going to hire me if they have any sense to do their 3D graphics, okay? But they will probably hire you because I've seen some of those models in your daily models. Oh my goodness, they're getting really good, especially for 20 minutes, okay? So please have fun with these textures, explore, poke around, okay? If you learned something, right, let me know. Let your peers know, right? Put a cool example or a cool image or something you discover into the Discord. That's what it's for, okay? This is not a competitive course. There are some courses on campus where it's wild. There's 60 people in the course, but I'm only allowed to give out 10 A's. that's like, that happens a lot in Ross, the School of Business. Is that like that cutthroat business mentality that I keep hearing about? Maybe. But like, so that this is not that kind of course. You can all get A's, okay? And I kind of expect you to, as long as you're doing the work. So help each other out. Do not see this as a competition. Please lend your knowledge to your friends and teammates. Don't copy stuff from your friends. But, you know, you can use the similar techniques. You can debate and discuss them and all that good stuff. Just literally don't send a model to your friend, okay? You'll probably be fine. Okay, any other questions or comments? Okay, remember, if you uploaded and submitted to that Google form your game controller daily model yesterday, I automatically moved it to today. It was a big pain. And you should already get the credit. So tonight at 2 a.m., you should get the portfolio generated and you should see your game controller there. If you haven't submitted a game controller, you have till the rest of today to do so. And the number of models that you must finish by the end of this assignment has gone down by 1 to account for that day that we just lost. Unfortunately, you also lost a theme because that theme had to get whacked. One of the themes that I had to get whacked to go from 41 models to 40. You know what theme got whacked? I was going to whack the American football one. And I was like, I kind of like football. So I didn't get rid of that one. I was going to get rid of one coming up that is a framed portrait theme. I mean, that one, I can't get rid of that one. That one's meant to get you doing texture work, right? I got rid of Rusty Nail. Yeah. Do you want it back? Should I get rid of a different one? No. You know, Rusty Nail actually sounds pretty good because like you can get rust in there by mixing like a couple metal textures. Oh, I'm kind of regretting it now.
Are you out of free draws? Are we out of free draws?
We got no more slots. They're all full. I have to get rid of some ideas. Yeah.
But wasn't
actually, yeah. We could get rid of some free draws, but I think like every Sunday I made a free draw because that's like, I want to chill and have fun at the end of the week, right? Otherwise, everyone will take Sunday off. So you should take Sunday off. You should take any day off you want, really. Just get 4 done per week. Okay, it is 3:20. I lied again to you. I thought we were going to have time today. I think what happens is I get on tangents when I realize I have a lot of time, and that eats up all the rest of the time. So anyway, please forgive me for that. Hopefully you find it at least interesting. And good luck to all of you, okay? Homework 3 is not devilishly hard. And it's a little bit shorter, maybe, at least in terms of number of questions, but please start it. Please start it soon, okay? If you have not, then you'll have a much, much more pleasant time, okay? See you next time. Take care. We got 1 hour of office hours starting now. Okay, everyone online, take care. Bye-bye.